Our project is based on VAST 2015 Mini Challenge 1. Dino Fun World is a simulated amusement park with size 500 meters times 500 meters. All visitors are equipped with park apps to record their movement information. A CSV file containing around 6 million of tuples is provided. Each tuple has time, ID, movement type, and position attributes. The data is generally clean. No visible missing data, no apparent dirty values, and the format is unified. Structurally, the dataset is not complex, but it is large. We designed visitor-oriented visualization to visualize the moving trajectory of each visitor and find out the anomalies. We also designed place-oriented visualization to visualize how the population distribution across park changes throughout a day. For the visitor-oriented visualization, we made a Python class person to process the raw data. We calculated the feature of each ID, including the absolute time visited and the time spent in each area and each facility, number of total check-in occurred, and the time they entered and exited the park. Based on these extracted features, we used the PCA to reduce the number of data dimensions into 2. In the scatter plot, the position of each dot encodes the position of the corresponding IDs wrote in high-dimensional space. We found in the scatter plot there are many dots are highly overlapped, which indicates that many visitors had a very similar moving trajectory as others. Therefore, we performed additional data reduction by using one dot to represent all dots in the nearby area. In this way, we got left part of figure 2. The overall characteristics of the visitor population are preserved. The route of each single visitor in the scatter plot was visualized by d3.js on the map of Dino Fun World. Detailed time, position, and movement information can be shown in the text when the mouse is on a specific point on the route. Each record of a visitor is represented by a circle on the corresponding position on the map. The size of the circle encodes the time spent on that position. The color of the circles encodes a rough time information. The later, the darker.
By tracking the change of the color and the size of the circles on the map, we can easily observe the general pattern of a visitor. We found abnormality tends to appear at the edge of each cluster. For example, the rightmost dot shows that the visitor with the ID 1781128 only stayed in the park for 3 hours, but stayed at the crime scene for 24 minutes. Therefore, the design enables the user to clearly track the individual movement and quickly detect abnormal behaviors. For the place-oriented visualization, we made a Python class place to process the data stored in person objects. Each place object represents either an area or a facility to record the population on that place over time. Using d3.js, we designed the place-oriented visualization with 2 components. On the left side is a heat map of the whole park. We divided the whole park into 10,000 squares based on the coordinator. The population of a square is encoded as color. The lighter the blue, the more population at that time. The whole graph gives a very intuitive view of the overall population distribution. Above the graph are 32 buttons, which represents time from 8 o'clock to 23 o'clock. By clicking those buttons, users can easily have a glimpse on the overall population distribution in the amusement park per 30 minutes. From the heat map, we can observe that most of the populations are distributed on the main road and its nearby facilities. The bar chart on the right side is a histogram of population over time in a region. There are total 5 regions which are shown with color blue, pink, yellow, green, and red, respectively. By clicking any square inside a region, the histogram will show how the total population in the specific region changes. Above the heat map, region name will be shown to indicate which region is chosen. By mousing over the histogram, time and population will be shown.